Hello, good morning to everyone. This is part 2 session of Minterm and Maxterm realization of Boolean function. In the last session, I have given you the introduction about what is a minterm and what is a maxterm. Please check over the earlier videos. I will post it in the description also. So by this session, you are going to learn the three topics. One is a canonical SOP form. The next one, it is a truth table. And the next one, which is a two-level circuit realization. Okay, we will get into the topic. Canonical sum of products. So sum of product is nothing, which is your SOP, right? You can see sum of product is nothing, which is your SOP. So we used to call it as a canonical form. So SOP, so S in the sense sum, right? So by last class, I have told you two symbols. One is this summation and another one, this is the pi term. So two terms I have given you by the last class at the end of the session. This summation, which is called as a sum of products. So sum of product of minterm. I hope you remember the minterm. So what is a minterm? Minterm should be represented by the letter small m, and in the minterm, so while you are considering a bar, that is considered as a complemented term, and a which is considered as a uncomplemented term. So the complemented term and uncomplemented term should be represented by the logical representation also, right? So how many logical representation you have? Logical representation 1 and logical representation 0, right? Okay. So A dash considered as a complemented form and A considered as a uncomplemented form. So the uncomplemented form should be represented by the letter 1 and the complemented form should be represented by the 0. So this is a minterm realization, whatever I have given you in the last representation. So sum of minterm. So sum of products, that is a sum of minterm. So check over this canonical SOP, right? What is this canonical SOP? Or every minterm for which the function's output f is equals to 1. And I have given you the basic gates also. There are three basic gates: AND gate, OR gate, as well as the NOT gate. Okay. So what is meant by sum? Sum means it is the addition operation. Yes or no? Yes. So sum means it is the addition operation. That's why what is the symbol we are using? Plus symbol. What is this plus symbol represents? Which is your OR gate, right? So OR, every minterm for which the function's output is 1. Here what you have to consider? You have to consider the output function which is equals to 1. Okay, so 3 steps to build that canonical SOP form, right? Step number 1. Check your step number 1. Scan the truth table and find every row where f is equals to 1. So what is your first step? You have to check your truth table. Remember truth table? What will be there in the truth table? Truth table which is having input as well as it is having the output. That is a truth table. Okay, these are the components available, right? So what you have to check? You have to check the output of the truth table. So wherever the function value which is equals to 1, output is nothing, which is your function f. Okay. So scan the truth table and find every row where f is equals to 1. That is your step number 1. So step number 2. Write the minterm expression for each of those rows. Wherever f is equals to 1 available, against that you might have some input values. Okay, these input values should be represented in the term of minterm. That is your second step. So what is your third step? Or all of those minterms together. What is meant by or? Or means it is a sum. So sum means what gate you have to use? You have to use a OR gate. So or sum all of those minterms together. Then the sum is capital F. See here, it is a shorthand notation. What is f represents? Function. So how many inputs I am using? 3 inputs I am using. input A, input B as well as input C. So what is my output? Sum of minterm. So list of the decimal indices where f is equals to 1. Okay. I hope you can understand these 3 steps. Based on the 3 steps, we will see one example. Okay. So this is a problem. We will use a 3 variable function throughout the rest of this lecture. Okay. So I am going to use 3 variables. So what are my 3 variables? Variable A, variable B and variable C. Again, I want to recollect you, that is 2 power 3. So what is 2 power 3? It is 8. So what is that 8? It starts from decimal 0 and it ends at decimal 7. So what is the decimal 0? That is 0, 0, 0. What is your decimal 7? 1, 1, 1. From where you are getting this? You are getting this from your 4 to 1 code. Okay. This is a short recollection of your. We will use this 3 variable function throughout the rest of the lecture. Okay. Consider f is equals to f of a, b, c. What is this? F represents function. So as I told, it is having 3 variables a, b, c. So if it is 3 variables a, b, c, so what will be your code? That is your 4 to 1 code. So what is your 4 to 1 code? This is a way 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 0 and 1, 1, 1. Okay, right. So what is your first step? You have to scan the truth table and you need to find wherever it is having the 1. That is your first step, right? Okay. So first step, where it is having function 1, 0, 0, 1. Next it is 0, 1, 1. Next it is 1, 0, 0. Next it is 1, 1, 0. Right? The first step. Right? Okay. So f is equals to 1, green rows. Where and all it is having 0, 0, 1. What is the decimal value here? This is 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So check here. 1 it is having 1. 3 it is having 1. 4 it is having 1 as well as 6 it is having 1. The way I represented it as rows 1, 3, 4, 6. These becomes our minterms for SOP. Right? Okay. What is the second step? You have to write the minterm. Right? Before that, we will find what are all the max term. So these ones are the minterm, then zeros will become the max term. So what are the max terms here? What are all the max terms here? 0, 0, 0 and 0 are the max terms. Where and all getting the 0? Decimal 0, right? So here I am writing it in the yellow color. Decimal 0, decimal 2, decimal 5 as well as decimal 7. So decimal 0, decimal 2, decimal 5 and decimal 7. These becomes the max term, right? Remember, minterm we used to call it as SOP. Max term we used to call it as POS. So last class itself I told what is POS. What is a POS? Product of sum. Okay. Right. So deriving the canonical SOP form. So what is your step by step? What is your first step? You have to consider f is equals to 1 at the rows. Where and all you got the f is equals to 1? 1, 3, 4, 6. Write each row's minterm, then OR them together. Okay. This is your second step. So first step you did. This is your second step. You have to write each row's minterm and then OR them together. Okay. What is a row 1? 0, 0, 1. See here, it is a row 1. That's why I have represented it as M1 because it is a minterm. 0, 0, 1. This is 0, this is 0 and this is 1. Okay. Right. So what is a complemented form? Complemented form to be 0 and uncomplimented form to be 1. Right. Whatever I have taught you in your part 1 also. So 0, 0, 1. What is your second one? Row 2. What is a row 2? Row 2 is M3, right? When will you get your M3? 0, 1, 1. So this is 0 complemented form. This is 1 and 1. Okay, M3. Next, it is 4. Row 4. What is row 4? That is M4. When will you get 4? 1, 0, 0. So 1, 0, 0. Right? Okay. What is the last term? M6. Right? Row 6, which is M6. When will you get 6? 1, 1, 0. 1, 1, 0. So 0 is a complemented form and 1 is a uncomplemented form. Right? What symbol you have to use? You have to use a or symbol. So that's why I have used the plus symbol here. Okay. So you have to write each row's minterm, then R them together. What will be your resultant? A dash B dash C plus A dash BC plus A B dash C dash plus AB C dash. Here I want to tell you one more thing. See, between each minterm, you are using a dot, right? You are using a dot. That dot is nothing which is your AND gate. So what is the dot? The dot is your AND gate. Okay. So this plus is your OR gate and the dot is your AND gate. So bonus thing, whatever you are getting here, simplification of that SOP, right? See, canonical SOP is not a simplest form, right? Means that it is having all the variables and many number of variables. So your aim is you have to do the simplest form. We will see how to do the simplest form. Check here. This is the F whatever you got. A dash dot B dash dot C, that is 0, 0, 1 plus A dash dot BC, I mean 0, 1, 1. So next it is A dot B dash C dash, I mean 1, 0, 0 plus ABC, that is 1, 1, 0, right? I mean 1, 3, 4 and 6. So you have to do the simplification, right? So while doing the simplification, please check the values. See, I have a term as A dash and C, right? Where I have the term A dash C, I will make it in the some other different color. See, this is A dash C and here also it is having A dash C, right? So A dash C is a common term. So what I am doing, A dash C should be taken, okay? Right? A dash C. See, check these two terms. Check these two terms. A dash C. So I have taken this A dash and C common term. What is at the mid? B and B dash. So what is at the mid? B and B dash. Check over the next term. See here, it is A dash, sorry, A C dash. Here also it is A C dash. Okay. What is a different term? B and B dash. I will show you by some other color. Check here, this green color combination, right? So A C dash, which is a common term in both the groups, which is a variance term B and B dash. So the way I have written it as A dash dot C dot B dash plus B. Here A dot C dash dot B dash plus B. Next, what I have to do? I have to find the value of this B dash as well as B dash. Remember, B dash is equals to 1. Okay. I'm trying to recollect this OR truth table. What is the OR truth table? 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, OR gate value is 0, 0, 1, 1, 1, 0, 1 and 1, 1 also 1. What is this 0, 0 represents? 0 means that which is a complemented form, and 1 means which is a uncomplemented form. So how can I write? I can write it as a dash plus a, which is equals to 1, right? So that is the way I have written here as, since b plus b dash is equals to 1. So what will be the available term then? A dash dot c plus a dot c dash. Okay, so a dash dot c plus a dot c dash. So what is the resultant here? This f is nothing which is equals to this representation, right? In the earlier, how many literals you got? Many number of literals. How many groups you got? 4 groups you got. But here you got only the 2 groups. So what is the inside here? F simplifies to a dash dot c plus a dot c dash. The exclusive or XOR of AC. Note, B disappeared completely. How it is getting disappeared? Because B plus B dash is equals to 1. So F does not depend on B at all. Right? That is a conclusion. Next term, you have to learn how to draw the two-level AND OR circuit for SOP. Right? Already you know what is SOP. What is SOP? Sum of product. When you will get the sum of product? Whenever it is having the minterm. When will you get the minterm? While it is having a M representation. So at that time only you will get it as a minterm. So it is a two-level AND OR. What is a AND? AND in the sense it is a product term, or in the sense which is a sum term. Both are actually the basic gates. This is a simple introduction for this particular topic, right? So you have to do the circuit realization, right? Okay. So each minterm becomes a 3-input AND gate. And all AND gate output feed one OR gate that produces the F. So for that, first I will take down the equation. Okay. Right. So what is the equation you got? What are all the values? So your values are 1, 3, 4 and 6. Am I right? So what are all the equations you got? That is 1, 3, 4 and 6. Right? Right. So what is for 1? What is for 1? That is 0, 0, 1. What is for 3? 0, 1, 1. What is for 4? 1, 0, 0. What is for 6? 1, 1, 0. Right? What are this 0 represents? Complemented form. A dash. What is this 1 represents? It is a uncomplemented form. So here it is A dash, B dash, C. What is the next term? A dash, B, C. What is the next term? A, B dash, C dash. What is the next term? A, B, C dash. Because what is your input? I am writing here. Your input is A, B as well as C. Okay. Check here. What is your first term? A dash, B dash, C. Right? Your first term is A dash, B dash, C. What is your second term? Where you are giving this? You are using a dot representation. What is the part you are using? You are using a dot. What is this dot represents? Which is your AND gate. What is this dot represents? Which is your AND gate. Okay. Right. What is the next term? A dash. What is the next? B. Next it is C. Again, what is a operation you are using? Dot. What is the dot operation? Dot operation is nothing which is your AND gate. So this also represent here. Next term. A, B dash, C. C dash. Can you see? A, B dash, C dash. Again, what is the operation? Dot operation. So again the AND term. Next A, B, C. See here, A, B, C dash. ABC dash. Here also it is ABC dash because your midterm is 6. Again, what is the gate you have to use? You have to use a dot product. I mean your and. After that, you have written? You are using a plus between every part. Okay. Within each group, you use the plus. What is this plus represents? Which is the OR gate. So means that I am taking one OR gate. To the OR gate, I am going to give all these 4 values. So what is my result? F. So that's why I have written F is equals to summation of. Summation of means it is sum of product. Sum of product of 1, 3, 4, 6. Right? That is your F. See here I have written F is equals to summation of 1, 3, 4, 6. What is this one? This is a midterm. So the way I represented M here. Okay. The same you can see here. I have written in the PPT as F is equals to summation of 1, 3, 4, 6. Okay. This is the way how you have to do the realization of the midterm on the 2-level gate implementation. You can ask me why we are taking it as a 2-level, because this is your level 1 and this is your level 2. Okay. That's why we called it as a 2-level implementation. Okay. Right. So the quick practice of SOP I am given here. Try to do by yourself. SOP checkpoint. Okay. Right. So this is the question I have given. For different function f of ABC, the output is 1 at rows 0, 3 and 5. Write the canonical SOP. Right. Again, I want to recollect you. So the output is equals to 1. Where and all you are getting that output 1? 0, 3 and 5 you are getting it as. So what is 0? M0. What is 3? M3. What is 5? M5. So you have to write the midterm for all the 0, 3 and 5. Next you have to use the OR term to add them together. Okay. So pass, work out, then check the answer below. Okay. So this is the answer whatever you will get. Right. Okay. What is 0? M0, 0, 0, 0. So means that everything is a complemented. Next 3. What is 3? 0, 1, 1. So 0 is complemented and other 2 are non-complemented. Next it is 5. When will you get 5? 1, 0, 1. You will get it as a 5. Okay. Right. So some assignment problems also I have given you. The due time is before next class. So before watching part 3, please try to complete all these parts. Okay. So for each function below. So 2 works you have to do. One, you have to derive the canonical form. Next, you have to draw the 2-level circuit for all the forms. Right. Okay. So problem 1, F1 ABC. F is equals to 1 at rows 2, 3, 5, 7. So why all the time we are concentrating F is equals to 1? Because it is a midterm SOP. That's why. Okay. So the problem number 2, again, the function is available at 1, 2, 3, 5, 7. So problem number 3, the function is available at 0, 1, 6 and 7. Okay. So please don't do this problem 3 as well as problem 3 don't do. Do the problem 4. Okay, what is the problem 4 I have given? Some different values I have given. PQRS. So PQRS means I have given you the 4 variables. Okay, right. So in the 4 variables, you have to consider where and all it is having 1. Where and all it is having 1? 0, 5, 10 and 15. So how many literals you will get in every group? 4 literals you will get in every group. Please try to work out this problem carefully. Okay. And the last one I have given you in the some other different form. Summation n. Instead of giving like this, I have given you as a summation m. 3, 4, 5. Okay. So means that midterm is available at 3, 4 and 5. So those values are having f is equals to 1. Don't do this part. This is for your next session. Okay. Don't do this part, but do this part. Okay. While doing the problem, if you have any doubts, post it in the group, post it in the comment box. I will give you the answer and I will tell you wherever you are having some wrong definition. Okay, right? So thank you so much for listening this session, right? So in this session, what do you learn? You learn what is meant by SOP, what is meant by Minterm, why we called it as a sum of product, and how to realize the equations by using a two-level implementation and all. Thank you so much for watching this session. Have a good day.